Hey guys, welcome to today's lesson. Today we are introducing trig functions. We're only going to briefly look at trig functions. I guess we'll see how far we go into it. You can really push yourself with this stuff, but at the moment I just want to look at the basic trig functions. That means graphing. What does the sine graph look like? What does the cosine graph look like? And we might even breach into what does a tan graph look like. Of course, there are parts of the functions that we can look at about pushing them up and down and pulling them this way and that way, but we want to look at the basic, we call it parent functions. So to begin with, what I'm going to look at is the graph of y equals x plus 1. And I would say, how would you sketch that function? How would you graph that? Now, later on, or earlier on, should I say, you might have looked at, you might put an x and a y table of values. You might put -1, 0, and 1. I then go -1 plus 1 is 0, 0 plus 1 is 1, 1 plus 1 is 2. I then go through and I'll put -1, 0 here. I put 0 and 1 through here for my y-intercept. I then do 1 and 2 up here. And I'd sketch my graph. You know, there's lots of ways that you might have done that. You might have done that in your head. You might look at the intercepts. Whole lot of things going on, right? What if I said to sketch a graph of y equals sine x, or graph of y equals sine theta? Let's go theta just so you can recognize that that's where my angle is. What if I say graph this? What's it going to look like? You know, you might say, okay, I'm going to do a table of values. Instead of having the x on top, I'm going to put a theta. I'm going to put my y on the bottom. Okay, the problem's going to be, what do you now start putting for those values on the top part? What's our lowest value that we looked at for an angle? You might say 0. Okay, what are some other values we've looked at? Like 30 degrees, 40 degrees, 50 degrees. So later on, you know, you can kind of look at things like 0, 90. If you think about our unit circle, 0, 90, 180, 270, all the way around to 360. Now, technically speaking, we can keep on going forever, right? I can even go reverse. I could go the negative angles, which you can have, believe it or not. So this is what I'm kind of looking at, and it's a bit strange, right? You're like, okay, well, what's sine 0? Well, let's get our calculator out. Sine 0 degrees, remember this is in degrees, equals, it says 0. Surprising. I might press sine 90. Press equals. We get 1. Interesting. We can do sine 180. Again, this is all just typing into my calculator and pressing equals. We get 0. Interesting. Sine 270. -1. Interesting. Sine 360. We keep on going and doing exactly. I don't have to use 0, 90, 180, but you can start to see why perhaps I'm using these values. What if you said sine 20, for example? What's going to happen on your calculator, do you think, when we do sine 20? We get 0.34. It's like it's this really small number, but recognize it's in between 0 and 1, but it's not a nice number. These are all quite nice numbers, because if I then put on a graph here, and notice this is now my theta, this is not my x-axis and my y-axis, what's the smallest value it was? Well, the smallest it went down to was -1. So let's do -1 down here. What's the biggest it got to? Got to +1. And noticing, it actually will never get above those two. Never does. Okay. Apologies for my dog again. He's a bit barky today. Okay. Now, so I've got my values here. What are my angles going up between? Well, they go up to 360 degrees at this particular instance. I'm going to go half of that is 180. In between those two is 270. In between the bottom two is 90. So I can see my nice steps that are going up there. And I'm going to plot some points. We have 0, 0. We have 90 and 1. We have 180 and 0. We have 270 minus 1. And we have 360 and 0. Now, that looks quite nice. It kind of has a little pattern. Now, of course, this is not a linear function. Linear function is straight lines. Therefore, we don't have a linear function. We most likely have a curved function. And this is what it starts to look like. Kind of like little parabolas. Not quite little parabolas, but they kind of look like little parabolas. Now, funny enough, if I keep on going through this motion and I push on 360, I add another 90 degrees, another 90, what you're actually going to find is that this graph kind of has this same motion that left and right continues forever. Now, often you might have heard of the sine wave, and this is why it's called a wave. It goes up and down, up and down, up and down forever, both either way. So what happens often when we're looking at these questions, they might say sketch the graph, and they might give you a domain. Now, a domain means a barrier. What's the lowest I want you to draw it from and the highest? And they might say they want your angle to between 0 and maybe 360 degrees. And they call that a domain. If they said 0 and let's say double that, 720, you're going to be going all the way to 720 degrees. Noticing it always gets to -1 and -1 and +1. It never gets above those. Now, of course, I could force it above those later on by doing like a plus number. Whole thing shifts up 1, or subtracting a number. Okay, the whole thing goes down 1. So it is possible to go above those two values, but then that we start talking about transformations, and down the track, that's important for us. But at the moment, that's what I want to look at. So you can see the sine wave looks like that. Okay, noticing it starts at 0, it goes up to 1, back to 0, down to -1, up to 0 again. Now, we're looking at 3 different types of graphs, right? We're looking at sine, cos, and tan. If I do the same kind of motion for cos theta, okay, so theta and y, I'm going to use the same values for theta, 0, 90, 180, 270, 360. So you can just change color there. Let's see what happens. Now I'm going to go in pressing cos 0. What do you reckon cos 0 is going to be? Often you're going to be wrong. It equals 1. If I type in cos 90, what's cos 90 going to equal? 0. What's cos 180 going to equal? -1. 0, 1. Okay, do on your calculator, see the values. Now, I'm going to plot them, just like I did with that previous graph. Now, noticing my x values, my theta values, I'm only using positive, so I don't really care about the other quadrants. So I'm going to go 90, I'm going to go 180, I'm going to go 270, and then 360. I'm going to put theta there, I'm going to put y here. My biggest value is 1, bottom value is -1. I'm going to plot my points. So 0, 1, slightly different to the sine rule, starts at 1. 90 and 0, 180 and -1, 270 and 0, and 360 and 1. Now, again, kind of looks like a big V, doesn't it? But we know it's not a linear function, so it's not straight lines. It's going to look like this, believe it or not. So again, we sort of see those parabola shapes. Now, we get this nice kind of cool shape. Funny enough, right, if we actually continued that sine graph, we go back up this sine graph up here, if I continued this one and looked at that portion of it, guess what the sine graph looks like? The cosine graph, but slightly shifted. And earlier on, we noticed things like sine 60 degrees, for example, was the same as doing cos 30 degrees. Okay, or sine 70 degrees equaled cos 20 degrees. We recognize that they were kind of equal to each other. And it's just a slight shift in my graph. They actually have the same graph there. It's a little bit, it's just interesting for later on. At the moment, I don't really care about that. I care about the cosine graph starting at 1, going to 0, -1, 0, and 1, getting the shape right. If I continued this forever either side, it's just going to continue on exactly the same way. It's going to look like that sine curve again, but it starts at +1 for 0, 1 for the y-intercept. Therefore, it's a cosine graph. So those two are kind of cool. As I said, if you're not sure how to draw them, just put in those 5 points, use the calculator, and you can figure it out pretty quickly. Most people will know that the sine, one looks like this and one looks like this. Just put the first value in. Sine 0, cos 0, which one starts at 0, which one starts at 1, and that often can help you to start with. Now, the last one I want to do, because they're the first two again, you don't really need to know too much of this. We don't do it too much of it in year 10, but it's just getting the idea of the shape of it. The harder one is going to be this one, which is y equals tan theta. And I am going to say it's much more challenging. Okay, if I put theta and I put y, and I do things like 0, 90, 180, 270, and 360. Exact same format. It's like being back in year 7, really. Okay, just doing a table of values. If I get my calculator right and I type in tan 0, and feel free to pause this and have a crack at yourself. Okay, we get 0. That's nice. Okay, that's kind of similar to some of the other ones. If I type in 1090 and press equals, ooh, something happens. Doesn't work. If I go and say 10,180, so 10,180, what do you come up with? You get 0. Okay. If I type in 10,270, what do you get? Nothing. Okay, that's weird. 10,360, press equals. I get 0. That's quite interesting, right? Now, there are two values that they can't equal, so it means it never touches it. That's interesting. I'm not sure if you've seen a graph where you get a line that never touches it. Maybe you have in the nonlinear part in year 9, and there are asymptotes, okay? A little bit like our hyperbolas. Tan theta, there was a value that we had that really worked nicely. Can you remember that value for tan theta? Think about tan 45. What did that equal? What was our exact value of tan 45? That was a nice number, wasn't it? It equaled 1. So what if we kind of start to sketch this graph out, right? We're going to put in our 90, our 180. We're going to put in 270 and 360. And I'm even going to mark in the 45s. Because when we get to 45s, for example, put 1, -1 here. When we get to 1045, we knew it equaled 1. Okay. 1045 here, but it's in the second quadrant, right? It'd be -1. Third quadrant, it was positive, it'd be up here. And the fourth quadrant, it was negative, it'd be down here at -1. I've got my zeros here, 0 there. Oh, can't equal 90, can it? Let's do a dotted line. It can't ever cross this line. Okay, 180, 0. Okay, I'll get to 270, you can't touch that line. All right, and then 360, 0. Looks really strange, doesn't it? Look what this is going to look like. Okay, this looks like a whole pile of cubic graphs. Remember a cubic graph looks like this? Okay, or some parabolas, upside down and shifting with a little point there. This is the same thing. Now, it's a much harder graph because you have asymptotes in here, okay, where the theta equals 90 and 270 degrees. It's so much more challenging than the other two graphs, but in saying that, it's all just cubic graphs. You know, if I looked left and right of my domain of 0 and 360, you would actually find that it would just continue on forever. Okay, they're my tan graphs. So look, this is much more challenging. I know if you can have access to Desmos, you can play around with them. It's a bit more challenging, but you can see that these graphs for tan, they don't have maximums. They're infinite, right? They don't have minimums because they're infinite, whereas opposed to my sine and cos, never got above 1 or -1. So the thing for us is, and I've shown you for the base how to construct them, we need to know that y equals sine x or sine theta looks like this. We need to know that y equals cos x looks like this. We need to know that y equals tan x looks like this. Now, that's between 0 and 360, of course. You know, of course, I'd ask you to put all those numbers in. I'd ask you to put these values in here. Okay, put 1 in there and -1 and 180 and 270, 360, all that kind of stuff. I expect you to put all that kind of numbers in. But that's, generally speaking, all I kind of want you to have an understanding of is what does the shape look like. Later on, we'll start talking about things like amplitude and periods and talking about all sorts of different things. But at the moment, it's just having a basic understanding of what does sine x look like, what does cos x look like, and what does tan x look like. Hopefully, this wasn't too challenging. Okay, it can get a bit confusing, particularly when I'm not in person, so you can't answer questions. But certainly, just having an idea about these three things, that my graphs look like this, that's what we need from you. Having a little bit of understanding and maybe using a table of values with 0, 90, 180, 270, and 360, that can help you to get those points and then kind of sketching a graph from there. Again, challenging. Hopefully when I get to see you, or Mr. Michelangelo and Mr. Finch get to see you, we can kind of help you a bit more with this stuff when we see you in person. Hope all is going well. It's not long to get back, so I look forward to seeing you all soon. Have a good one.